In this video, we're going to look at solving systems of equations that result in solutions that are not one solution. So we have two equations here. Notice they're not in the same form. One of the equations is solved for a variable y. That makes this system prime to use substitution. So I am going to take this 3 plus x and I'm going to substitute it into the first equation for y. I always substitute into parentheses. And notice the result is one equation with one variable. Now, these parentheses, I don't need them there because I'm not distributing anything. I don't have a negative sign out front, so I'm simply going to drop them. And now I'm going to combine like terms. And notice what happens. My x variables, they cancel out. The result is 0x. And the equation that I'm left with is 3 is equal to 4. This is not a true statement. It's a false statement. And anytime you're solving an algebraic equation and the result is a clear false statement, that means that that equation has no solutions. So that is actually what we're going to record as our answer. Okay, there's no value of x or y that are going to make both of these equations true. Let's look at another example. So in this example, both of these equations are lined up with each other, so it probably makes the most sense to use elimination. I'm going to multiply the first equation times -2, and the second equation is just going to stay as is. So multiplying the first equation times -2, I get -4x positive 2y equals -2. And now, notice I was looking at my y variables the entire time. I have y variables that are both 2 and they're opposite signs. So when I add these up, I know those are going to cancel out. But look what happens to my x's also. They also cancel out. So I am left with 0x plus 0y is equal to -2 plus 2. Those end up equaling 0 too. So this equation I can simplify to 0 is equal to 0. I have no variables to solve for. But unlike the last example, where the result was an equation with no variables, but a false statement of 3 equals 4, in this case, the result is a statement that is true. 0 does equal true. And what this means is that it does not matter what value of x and y we happen to pick. Your x variables and your y variables are always going to cancel out in this situation. So we end up saying that they are infinite solutions. And let's just look at a quick example. Let's just say x was equal to 1. Okay? Let's substitute 1 into the first equation and see what happens. Okay, so we get 2 minus y equals 1. Subtract 2 on both sides, we get y is equal to 1. Now, let's substitute 1 into the second equation and see what happens. 4 times 1 minus 2y equals 2. So this is 4. I'm going to subtract 4 on both sides. Divide both sides by -2, and y is equal to 1. It's the same point in both equations. Now, I want to clarify something. Our answer is infinite solutions, but that does not mean all solutions. So the point 1, 1 works in the first equation and the point 1, 1 works in the second equation. That does not mean any point is going to work. That does not mean that the point 1, 7 is going to work. In fact, 1, 7 is not going to work in the first equation, and 1, 7 is not going to work in the second equation, because when x is 1, y is 1 in both of these equations. So when we give an answer of infinite solutions, that does not mean all solutions. Let me just stop that video.